if there's something that he doesn't know or understands, can't figure out. And all of those are general things that you should be taking notes on. Client had a struggle figuring out this. Client seemed to take longer than we would have liked to do this. The client may still give you positive feedback on that. Oh, that makes sense. But if you personally were thinking that someone who hasn't used this application before should be able to figure out how to do this within 5 seconds, and it takes them 15 seconds, then maybe that's something you take a note of. So watch the client's experience with it as much as you are the client's feedback, because maybe you notice something that even the client doesn't that could be improved. So I guess now that we're a couple days out from that, we should talk a little bit more in detail about exactly what that process will look like. So period will start. I will, during that 10-minute passing period beforehand, I will try to get a sense of who needs to be somewhere at a particular point in time. So just like last time, I will order the groups in the order that you will present to the client. Because this is such a large class with a lot of people in it, there will be a timer associated with that meeting. And by the time that meeting is over, you're unfortunately done, because the client has a limited amount of time. The client can't meet on another day or another time like I could for the group that I couldn't get to. Still sorry about that. But client's time is set in stone to be that period. So you have a short amount of time to get that feedback about the program and make sure that you still have time to get information from the client about what the next sprint's requirements are. What is he looking to see by the next time that you meet? So all of that has to be done within that time limit. Anything that doesn't get to is something that you won't have that information ahead of the sprint deadline. So it's time for you to get that feedback, know what you're doing at Sunday. Further questions? Yeah.
Well, I guess just to re-emphasize that. So next Wednesday, we're supposed to be probing him for Sprint 2 requirements.
Yes, that is one of the questions that you will have is, what are you looking to see next time? And then someone, at least one person, should be taking notes. In fact, I would have a role that is a note taker, someone who walks in, introduces themselves to the client, and then from that point on, their task is take notes. And everybody else should be asking questions, fielding questions. Yeah.
So you mentioned that you're going to look for everyone speaking and saying something.
Yes.
Like with that note taker, are they also expected to contribute to the conversation, or more just like they're?
I am less concerned with the person who's taking notes, as long as they're engaged in taking good notes. Although if they contributed something to the project, assuming everyone's contributing something to the project, when it becomes does this person want to talk about this functionality? Then that person can absolutely step forward and contribute in that regard as well. And you may want to rotate who's taking the notes and be ready for that. But yeah, in general, just looking for everyone, for it to feel like a company is presenting and not like the one person who worked on this is presenting and everyone else is just sitting there waiting for it to be over. Other questions on that? Other questions on upcoming schedule? There's not too much else aside from we have a sprint deadline week from last night. So sprint 1 deadline is coming up upon us very quickly. Make sure that you're integrating as you're finishing components, especially ahead of Wednesday. You've had a sense of tested whether this actually works. Play the role, have someone play the role of the client and try to use the application on a fresh install before you ask the client to do it. And then make sure you're integrating again in plenty of time before Sunday's deadline. You do not want things to surprise you in that last hour.
How will the client have to get it up in our meeting for?
For time purposes, I will probably say come prepared with it on one of your local machines. And that way you can just set the machine in front of the client, have the client play around with it. Be careful of things like crowding the client. If the entire group is trying to see what they're doing, their personal space may feel violated a little bit.
Can we tap into like the projector so the rest of the group can kind of see what the client's doing with that, or like we have
Yes,
HDMI?
you certainly can. If you want to set it down and use the HDMI right here for that, and then have everyone in your group in the chairs have the client up here, sure. You're free to direct the client to do what would be best for your group. As long as the client is okay with that. No ridiculous requests. It would be best for our group if you jumped out the window. Anything else before we get into testing? All right, so I guess I'll kind of put you in a big picture role of where we are in the class at the moment. So we've finished all of the class material for the first sprint. We're going to be talking about some material for the second sprint over the next week or two, and then we're going to start deep diving into more for the last few requirements as well. But we're going to be spending a bit of time talking about testing. I just wanted to query the class and get a sense of, I've done this before. It was about half and half for who's taking 212 and who hasn't. But who feels like they have a reasonable handle on unit testing with JUnit and Java? That seems like about half. So this is going to be a little bit more challenging than I think it has been in quarters past, where 212 was a prerequisite to this course. So I'm going to try to use that information and double down a little bit on testing practices and testing procedures, because testing will start to be part of the rubric for this starting in the next sprint. And I can say this as the project manager because testing is really important. I want to be able to validate and verify your program just like you should. Question in chat about what time chapter 3 should be read. And at this point, it's just something that will be done in advance of the quiz that goes over it. So I have the associated deadline by the Monday associated with, you should have, according to the syllabus, read chapter 3 in advance of today. But I am not placing a particular deadline on that. Just make sure that you're ready to go by the time it's on a quiz. And the quiz study guide will tell you which quiz is going to have which content on it. But it's basically, I think it's 1 and 2 was on the first, or was it just 1? I honestly can't remember. I think it was just 1. 2 and 3 are on the second, and some combination of them. I didn't look into it, nor did I look it up before class. I can do that if people are curious. So deeper dive on testing for the moment, and we'll go from that into something on model view controller, and then from there directly into design patterns, because I think all of that is going to be very important, especially if this is the only place in the curriculum that you're getting it. So a little bit of background on that. 212 was the course that covered all of that material, and in my and other faculty's view, it was the wrong place in the curriculum to be giving you that kind of background. You couldn't really apply it, and the way that you were applying it were in labs that didn't really, at least in my opinion, have the outcomes that could help you to determine what it is that you had applied to be able to apply it again. So it felt like it naturally much more belongs in this class than that class, because as you're designing large scale code, you can actually put in the design patterns for scalability, for refactoring, that allow you to actually circle back to it and see the benefit of what you have implemented. So that's why I'm trying to do it here. The issue is that it's very crunched in here. There's a lot of content to cover in a short period of time, and that class was full from start to end of content, from unit testing to code smells to all of the different classes of design patterns and what they do. So I'm going to do my best to cover that at a reasonable level, but know that there is probably more for you to do to be prepared for interviews. So the source that we will use throughout the class, I highly recommend people spend some time over a break and just get a bunch of experience with it. But I'm going to dive in as to not waste too much more time. Any concerns before we do that? All right, let's do it. So I'm going to argue at the very beginning of this that testing is probably even more important than the code that you write. Just because testing is how we can ensure that our program behaves in certain ways on particular inputs, which can become a vital part of knowing whether our code is working or not. So the actual code that you write defines the behavior that your code actually does, but the code that we write affects the systems that are around us as well. So because software has exploded to be responsible for so much more than it used to be, testing has become more and more complicated, but also more and more necessary over time. We talked about some of the very costly software failures on the first week of class, but kind of reiterating that if you produce buggy code, the end results can often be more costly than the time or effort that it would have taken to get it right in the first place. So everyone should always be on the same track, on the same mindset, in the same mindset of making sure that the code that you produce is the highest possible quality. We've already gone through most of this, but you can see that entire power outages happen because of software errors. This has happened historically. We've seen plenty of large scale failures, and even at the smaller scale, it's a significant problem. So how do we actually go about planning for the associated software quality?
Light it on fire.
Light it on fire and see how it responds. It's kind of the equivalent of that. So you can't test in quality. It should be built from the ground up for that quality. So the entire development process should be focused not on just getting something working, but on getting it working correctly from the ground up. So we're going to introduce two terms that are important to distinguish from this. The first is verification, the second is validation. Has anyone heard those two terms or know the difference between verification and validation before we go over it? They might sound like they're the same thing, but there's a very important difference between them. So validation, you can think of kind of like prevention. The question at the heart of that is, are we building the correct product? And verification is, did we build the product correctly? So did we build what we were supposed to? And is what we built defined to do what it's supposed to do? Both of these concepts are needed to make sure that the software that you produce is quality software. The gold standard is if you can write a program that without your input at any point can both do the validation and verification, that would be ideal. Of course, that's not necessarily possible in every environment, so getting as close as you can to that gold standard will be useful. So let's start with validation. What do we do to validate making sure that we're building the correct product? First thing you can do is code reviews and meetings, especially early on with the client. But it helps make sure that the associated documentation is correct. It's both what the client is looking for and that everyone is on the same page about what we are building. It means that everyone, at least in a small group like this, is involved with all of those steps, is involved with the creation of the documentation, that is involved with the editing of the documentation, evaluation of the documentation, and the plans and the design. So anything from code walkthroughs and inspections, all the way up to talking to the client at the very beginning of the project. So that's oriented toward validation. Once we start the coding process or the design process for the coding process, we switch from validation to verification. And we will start writing for and ensuring things like the associated different testing types, unit integration, system regression, performance, and acceptance. We'll go into each one of those in detail here in a moment. Heck, I'll give you an overview while we're staring at them. So unit testing is done at the small unit level. So at the method level, at the small, as small a fine grained unit as you possibly can get. So independent of all of the context, how does this small piece work by itself? Is it doing what it needs to? As you start to incorporate, I'm going to set up these other things. You can start to see how the paths to those unit tests become very large. If this does this and this does this and that does this, and then I run this small piece of code, what happens? So it becomes infeasible to write unit tests to cover the entire program, because the flow of your program, there are lots of possible inputs paired to lots of possible outputs, possibly infinite. And you can't possibly verify everything. Integration tests are when you write a component and I write a component, and now we actually go test whether they communicate or work together correctly. So that's integration testing. System testing is once everything is in place, how does the system work together? So you might think that that's involved with integration testing, but that's only really thinking about two components interacting. System testing is all components working together correctly. So there are long chains of telephone that's played between the components and talking between those components. Regression testing, something that used to work should still be working after you add additional functionality or go through some kind of code redesign, rework of some kind, just making sure that what used to be functional is still functional. That is a very useful thing to be able to say and do. Performance testing is something like if you're making a game and you expect 10,000 players and you advertise a bit and gain some traction, and suddenly there are 100,000 players who want to play your game. What are the bottlenecks on your server? How many people can be logged in at a time before the time the server takes to respond to those queries is going to be longer than the player starts to notice that there's lag in the input and output, or they have to be in a queue for some kind of decision that's being done, making for long load times, or rubber banding, or anything else that you might have noticed due to server problems. So performance testing helps you to be able to ensure that any hardware that you're relying on for your software is going to perform at the level that you expect. Finally, acceptance testing is done with the client based on what the client was expecting. So usually you're going back to your user stories and making sure that we implemented our user stories from both our perspective and the client perspective. We wrote tests based off of what we communicated with them, and now the product to be accepted. So lots of different testing types. You can envision, if you were a company, spending half of your development budget on testing is standard. Once your code is done, once it's been designed, testing is the single most time-intense, resource-intense activity. It's not actually development, it is testing. If you don't do very much early testing, you'll find the cost of development increases. So even early testing will save time and energy and effort. And if you have any hardware software integration, so whatever it is that you are running this software on, is it an embedded piece of software? And once it's done, it's going to be embedded in that, you won't have access to it. Is it something like, for a game, you expect it to be able to run on a bunch of different CPU, GPU architectures? So there's a lot of actual system testing that goes on to make sure that the environment that you're running this in is successful. It's important to be able to be behind the associated testing process. So if you don't know why you're writing a test or why a test is useful, then it's not going to get written, and or it's not going to get written well. So recommendation is to think about what do you need to verify and validate the entire approach. And given the time constraints that you have, prioritize the tests. So maybe basic functionality is the most important test that you can ensure. I want to make sure that for a typical workflow, this program does what it's supposed to. Then you can worry about important edge cases, security, all the way down to very unlikely to see edge cases. So you can start to rank the associated tests and just knock off the most important ones to the least important ones. Once you know about code coverage, which tells you how many lines or proportion of lines in your code do you have tests written for, being able to design for the associated coverage level. When do you reach the point of writing more tests isn't going to reveal more bugs at a level that is worth the time investment or the monetary investment? When do you reach that point? So all of those are discussions that need to be had before everyone is on the same page about testing. When should we be starting to test? And the answer is as early as possible. You should be designing your test suites as you're designing your solution, designing what your code is going to look like. So even as early as your specification document, even as early as when you're writing your user stories, you can start thinking about acceptance tests, break those acceptance tests down into how do we ensure that we are delivering exactly that? Do we have that proof in test suite form, or do I have to run my code 5 times and say, see, it didn't crash once, which of course is not going to do, the client will not be happy with that level of coverage. Every person writing and thinking about the test should be able to determine what is each written test trying to verify about the program. If you don't test, things get very expensive, especially due to lawsuits. You didn't produce what I told you to produce, lawsuit. You produced something, but it doesn't perform the way that we agreed upon, lawsuit. You produced something and it actively hurt my business, lawsuit. So yeah, testing is extremely important. Knowing that you've tested well is important. Being able to validate that is important. But yes, software test tools are very cheap. So we should be making sure that we get our money's worth out of them at the very least. If you're planning some tests, thinking about them in terms of deliverables is excellent. So what is the associated approach to the test? What is the objective? What is the scope? What are the associated entry and exit criteria? Meaning, what are the associated preconditions and postconditions? What needs to be true in order for this test to even be run? And given that this test ran, what are the associated outputs? What should be guaranteed to be true about the state of the program from that test having run? Then we can talk about scenarios, high-level descriptions of functionality, cases, what is the procedure? How do we ensure that we're fully testing an aspect of that feature? All items and results that must be covered. Grouping tests into associated categories, making sure that all of those categories have decent suites written for them to ensure the functionality of each of those categories. Step-by-step instructions, detailed results for some person who's executing tests to follow when they're doing those tests, running those tests. And in general, at some point, we should embed these tests into our GitHub procedure. So in general, we're going to come up with an associated test plan during the analysis phase. So as we're analyzing and starting to design, then we come up with the plan for testing. we should be breaking that down into unit tests, system tests, and integration tests to make sure that we know what kinds of tests we are writing. Do they focus on a unit within a single developer code? Do they focus within when we are integrating components together and testing the functionality of how our components communicate with each other? Is that when that test is happening? Is it happening during system testing? Once all of the integration testing passes, now we can say, does the system do what we designed it to do in the first place? There can be either static or dynamic techniques. So static is more analyzing the code, so that the code is not being run while you are doing this test. And a dynamic test will involve executing the code and determining the associated output from the code itself. So something like a code review could be considered a static test in some way, shape, or form. Someone is logically analyzing or even potentially trying to run the code in their mind and seeing what issues arise. And that can be significantly faster due to the multi-parallelization of human brains as opposed to trying to come up with an associated unit test that's going to test that same functionality. Tests can be automated or manual. If they're automated, a computer is running the test. Manual, a person is leading the test. We talked about inspections and walkthroughs, and desk checks can be added to that. But moving past all of that, I guess we have technical definitions here of each of the different kinds of tests, which I've kind of gone over. Unit tests, very small grain, based on the smallest unit that you can possibly test. Any errors within that small piece of code. Integration, all of the modules compromising some element of a project, bringing those together and testing them together. We'll talk about top-down versus bottom-up integration. There's regression testing, which we talked about. Software that was previously developed and tested still performs like it did when it was tested before and passed. Anytime that you enhance software, change software, develop something, change associated configuration, any of that could potentially break tests that passed before. So we talked about system testing, we talked about performance testing, and acceptance testing. Making sure that the people who are actually using the software accept it in its current form. Is it useful software from the end user's perspective? Any questions on anything so far?
So for the integration testing, we would be checking, say, making sure our classes and our relationships end up together and such like that.
Yeah. The example that I was using for this, for every group that I could remember doing this for when I talked to you all, was the person responsible for the class design and the person responsible for the method design. The method needs the associated class. So if you're on the same page about how that was designed, then when the method goes to iterate the classes and grab the associated class that contains this method, that will succeed. If you were on different planets when you designed this, the code might not work together. If one person designed for an array list and one person designed for a tree map, then the associated method calls will not match. And what one person wrote will not go and fetch a method from what the other person wrote correctly. Even though as it was in development and as it was tested, maybe someone made a very basic array list and said, yeah, see, this array list goes and fetches it from this basic array list. So my code works. And the person who wrote it as a tree map, of course, now when you bring it together and ditch the basic version that the person making the method wrote, it doesn't work in integration anymore with its full functionality. So entire purpose is to confirm that the system satisfies the requirements. There's no way to verify that without actually going through and validating that it works. And yes, if you test well, it should reveal the most bugs or the most errors. Good testing reveals the most that is wrong. Bad testing says everything is good when it isn't. So you should write tests to reveal errors, not write tests to pass code. Just because the tests pass does not mean that those bugs have gone away. Testing, of course, has to be planned. You can't just write the code and then at the end of that say, how can we test this code? Because you're actually already biased by having written the code. You know what the code should do because you just wrote it. So any bugs that you put in the code might be bugs that you put in tests and assume that it runs a particular way because you're looking at the code you already wrote and you want to make sure that it does what it already does, which is, yes, it does this incorrectly. So if you write the tests based off of the specifications or off the design, before you end up going and implementing it, you will catch more errors that way.
Is that why like developers and testers are usually separate
Yeah.
teams?
Yeah. But we want you to be able to do both because both are very important. And if a developer is thinking about testing as they develop, the testers will have less to do and the testers will be your friends more and want to hang out with you outside of work more and not complain about you behind your back outside of work, the people they choose to hang out with outside of work. So we can break down test cases into three pretty typically large bins. The first is typical system use, what you expect average users to be utilizing fairly frequently. So if you're imagining that you've written a linked list, then this linked list functionality, you expect people to be adding at the end very frequently. So that is typical system use, yeah.
I've also heard to kind of subvert, the need, if you like have to be your own tester, writing the tests first and you know, that.
Yeah. We will talk about test-driven design later on, and there may even be a future sprint where I ask people to adhere to test-driven design and write all of your tests and commit all of your tests to GitHub before you start implementing a single line of code, just to see how it goes.
Oh, so I see you hate us.
Curious how that will go. So, yes. First one was typical system use, then there's critical system use of what happens when maybe something happens that causes the system to fail completely. So as you're using this linked list, if you were to run out of memory, how does your program handle running out of memory? How does your program handle when there is a particular error that it's not a weird error, it's just it's an error that causes behavior that's hard to recover from? That might be critical system use. Abnormal system use is an edge case. It's something that you don't expect your user to be doing very frequently, but when it eventually shows up, you want to make sure that it's handled well. Something like when they try to add a class that they already have a class with that associated name. You don't expect them to be doing that, but you want your program to be doing something that is intelligent when that does happen. And of course, we want as much of this as possible to be automated, because if you're writing tests and then have to run your entire test suites every time you make an associated change, that becomes very, very tedious very quickly. So eventually, we're going to talk about continuous integration and building test suites into GitHub to make sure that when you commit code, that it'll be rejected unless all of the tests that you've written so far still pass once you put in that code. So that's integration, and it works great. So we should begin testing at the small level, finding and correcting small mistakes within methods. So you want to think about starting with unit tests, start moving from smaller scope tests to larger scope tests over time. moving from unit testing to integration testing to system testing. So unit testing involves one person's code and one unit. Integration will involve two different modules written by two different people, so it's larger in scope. System testing, the entire system, quite possibly everyone contributed to this code. But you can imagine that if you try to identify where a unit testing granularity bug occurred when you're at the system testing level, you have to comb through the entire system to figure out where it is. If you can find it at the unit test level while you're trying to test just one method, there's a lot less that could be wrong in a few lines of code than your entire project. So less time will be spent debugging if you go from that small grain to large grain rather than the other way around. Performance and regression testing is not necessarily within the same scope. Performance testing whenever you're relying on hardware or you change your hardware. And regression testing whenever you make enough of a change that tests may have been rendered. Something might have broken. Hard to tell exactly what that is without knowing exactly what domain you're in. So evaluating testing is difficult. But not too much new here. Goal to find errors. So I actually have a problem for people to work on. So consider a program that has 3 if-else statements in them. So there's an if-else, followed by an if-else, followed by an if-else. So how many possible states are there to test at the end of 3 if and else blocks?
None of them are nested at all.
Correct, they're all sequential.
8, correct?
8. So let's actually draw through this. So we have kind of branch 1, 2, that's your if and your else. 3 and 4, if and else, and a 5 and a 6 that is an if and an else. So the goal is how many programs can we construct that go through either the if or the else, then the if or the else, then the if or the else. So we could do the program that goes through 1, 3, 5. If. We could go through if else, 1, 3, 6. Finish this off for me. How many are there?
Two, three, five. 2, 3, 6.
Mhm.
4, 5.
How many are there?
I still think it's 8.
It is. Yeah, it's 8. I just heard some disagreement between people, so I wanted to make sure that we were all on the same page. There are 8 paths through this. We have a base choice. There are 2 things that we can choose between, the if and the else. And there are 3 successive decisions that need to be made. So 2 to the 3rd is 8. That level of intuition will take you so far. So now, how many tests should you write, given that there are 3 successive if-else? Something like 9, something like, assuming there are some error cases, etc. But there are now 8 possible paths through this, so you need at least 8 possible tests to see, is the end state of where we were at the beginning, is this what we expect, given every possible path through these branches? Yeah.
Also, like, if that was the case, if there were 6, if there were 5 different if statements we just all those into helper methods to make this testing better.
With the same flow, I completely agree with you, but there would still be 8 possible successions. It would now just be which order are the methods called to produce the same logical flow. So because we have large branching factors in computer science, we have to be able to handle and analyze what happens when we do that. So
You're
Yeah.
making a joke about Undertale.
probably, not intentionally, but I'll go there and make it anyway without knowing more than what I'm saying. Jokes are good. What happens if there are 20 successive if-else statements? How many unit tests do we need to write to be completely sure that every possible path through these 20 if-else,
It's 2 to the 20th,
which is approximately how much?
big.
Yeah.
That is literally hell no.
So 2 to the 10th? Anyone know 2 to the 10th off the top of their heads?
2 0 0 0 0 0.
2 to the 10th,
Oh, 2 to the 10.
yes, is 1024. So base 10 is actually kind of helpful here for this is the one place thinking in base 10 is actually okay in talking in binary. 2 to the 10th is 1024. So you can think of it as an underrepresentation as about 1,000. So 2 to the 20th is 1,024 times 1,024. So in a very approximate case, this is about 1 million. 2 to the 30th is higher than 1 billion. 2 to the 40th is higher than 1 trillion. It gets less and less approximate as you go because the 24 will continue to multiply by itself and start to have an effect. But you can start to see about how much things explode in nature by doing that. So 20 if-else statements would you need about 1 million tests, over 1 million tests to test every possible branch through that. And it only takes 20 statements to do that, which is pretty insane.
Would it just be creating a loop inside the test itself to test all the possible states?
I mean, how long is it going to take to test 1 million states? It's going to take a while. How much, if you want to build this into your compilation process or in a continuous integration form, whenever anyone commits, how much time is that adding to the commit process on GitHub?
Let's say just do it on the acceptance test only.
That's dangerous because if you're at that point, you figure out something is wrong. How much development time has there been between when you could have run this and figured that out and now? So you run this test for the first time and half of them fail. What happened? So yeah, testing super important. Implications. What do you take away from this idea?
Nested branching paths that can create as many scenarios are a bad idea. Most of the
Yes.
comments will be.
Yes. So if you can create independent tests to say that what happens from this if else does not affect what happens something later on, this becomes a statistical independence test. That means that you can test them separately. You don't have to test what happens in each case when I do this. So being able to determine it doesn't matter what happens here for what happens here, and being able to split apart your code and think about it in terms of even math, it helps you. Not necessarily better. So in general, highest grain for testing. Test for what's going to find the most errors with limited time and effort. So we have 2 big limitations on us. We have the time that it takes to develop associated unit tests. Then we have the time that it takes to run those associated unit tests. Those are the 2 big constraints. So we want to focus on, we can't write tests for everything. So we're going to write the most tests that we can that identify the biggest problems or the most sweeping problems, and then hope the rest works, which is why unit testing by itself doesn't solve more than 25% of the bugs, doesn't find more bugs than that in general. So in general, you'll want to develop some test scenarios. Test scenarios are general business requirements, great. So a flight reservation application, you might do something like, I want to test the login functionality. But that's going to break down into an associated series of tests about what happens when I log in with correct credentials, what happens when I log in with incorrect credentials, what happens when I log in with SQL injection. What happens, there's a lot that you could do in the scope of that test. Check that a new order can be created. Great. What happens when you attempt a new order with valid information, with invalid information, with SQL injection? If there's an existing order, check that it can be opened. What happens if the order exists but is in an error state and you try to open it? What happens when thinking of all of the possibilities there and making tests for each of them so that you know what happens? Because even if it's a side case and that error leaks information, that could be a security risk. Knowing more about how your program actually works. Let's see. What questions do we have, especially questions that we have that might target the process that we are doing in this class? It's like how in general are tests written? How do we think about, how do we design them? Those kinds of questions.
I've been basing mine off of the user scenario and task listing.
Yes, that's usually a good place to start.
For all like the edge cases too, I would feel like those should all be.
Yeah,
part
if
of
you
that,
design
and then
scenarios,
the-
scenarios
the-
build really well into tests. Given tells you what to do before you start the test. When tells you what the setup of the test is, then tells you the post conditions for the test. So given that all of the setup is done, when I execute the lines of the test, then the test passes. The associated post conditions for the test have been met. So I think what I'm going to do tomorrow, given kind of what I've seen and observed, is going to go into a little bit deeper dive of making unit tests. This may be a review lecture for those of you who have taken 212. I'm not sure, but I think a little bit more could be done from the actual design perspective of slides that I wrote for 212 that I think Sarah may have used, but I'm not sure or not. But I'll go into a lot more of how to write unit tests in Java for those of you who haven't seen as much of that before.
That'd be helpful.
Can you show it
It's been a
on,
while.
can you show it on VS? Because it seems to, the dependencies seem to be built into IntelliJ, just VS does not like them.
Yeah, we'll see what I can do. But I'll introduce that tomorrow as kind of a finer grain. Here are the general ideas. Let's go see how it's actually done.
I do have a more high level conceptual.
Yeah.
Yeah.